Identify the species present in each solution. When soluble salts are placed in water, they dissociate completely into their constituent ions. NaF dissociates to release Na to the power plus and F to the power negative. NH4Cl dissociates to release NH4 to the power plus and Cl to the power negative. Evaluate the acid-base properties of each ion. Salt hydrolysis to determine which of these ions reacts with water to form an acidic solution. Analyze their strengths as conjugate acids or bases. Na to the power plus is the conjugate partner of the strong base in AOH. It has negligible acid strength and does not react with water. Cl to the power negative is the conjugate partner of the strong acid HCl. It has negligible base strength and does not react with water. F to the power negative is the conjugate base of the weak acid HF. Because HF is a weak acid, its conjugate partner F to the power negative acts as a weak base, hydrolyzing water to form OH to the power negative ions and making the solution slightly basic. NH4 to the power plus is the conjugate acid of the weak base NH3. Because NH3 is a weak base, its conjugate partner NH4 to the power plus acts as a weak acid, hydrolyzing water to produce hydronium, H3O to the power plus, ions, and making the solution slightly acidic. Select the corresponding reaction equation. Since the ammonium ion, NH4 to the power plus, is the species responsible for generating hydronium ions in solution, the hydrolysis reaction is represented as NH4 to the power plus H2O is in equilibrium with NH3 plus H3O to the power plus. This matches option C. The correct answer is option C. NH4 plus H2O is in equilibrium with NH3 plus H3O plus.